Please open up your books to page 48. We'll be using this presentation to fill in the page. This presentation is going to talk about some of the important information we need to know about the moon. It's going to start to get into why is this moon so important to us. Yesterday, we did a lab where we looked at the different phases of the moon. If I put this picture this way, this picture represents exactly what's in your book on page 52. You have your sunlight here, and then you have the different phases as we go around. You start off with your new moon phase, where you don't see anything. Say this is us here on Earth, and we don't see anything. And as we continue to go around, we start to see the moon phases like we did yesterday. So where did this moon come from? There are several theories about the moon's formation, and this is just one. So the scientists believe at one point in time, Earth wasn't perfect for humans. And at this point in time, when Earth wasn't so perfect, something collided with it. Almost another planet collided with it. Or something planet-sized collided with it. So if you look at the picture, this would represent Earth, and that would be the planet-sized object that collided with it. So materials from that outer layer of the Earth, which is like right around here, were ejected into our orbit and started to form a ring around the Earth. So it started to form a ring right around here. And because of what we know about gravity, that ring started to form around here, and as it started to form, the materials clumped up together to start to form our moon. So there's lots of other theories out there, but this is just one particular one that many scientists believe. We're going to move on to a couple of surface features that are important to our moon. The first one is called a maria. You might see the maria referred to as a mare. Maria is just a singular form of the word mare. And what these are seas on the moon. Now, not like our seas that we know. They're not water, but they're actually dark, flat areas on our moon that are hardened rock that were formed by lava billions of years ago. If you look at these dark areas on the moon, these are all different mares that are on the moon. So these are all different areas that at one point in time were lava, and they have hardened to form the rock that we know. That rock is called Rigolith, and it's also like a rock and almost like a dust as well. The next surface feature is one that I think many people know. Craters are large round pits caused by meteors, chunks of rocks and dust from space. If you look, this is caused by different impacts. Now, our moon's a little bit different than our Earth. It's not as protected, you can say. Our atmosphere breaks down lots of rocks that come towards us. Our moon does not have the same kind of atmosphere that we do. The last surface feature is called highlands. And highlands are like our mountains. They're like the raised areas on our moon, but they're lightly colored and unlike the mares. When we want to talk about size and density of our moon, we want to talk about a couple of different things. The first thing is our moon is 3,476 kilometers across, and that's a little less than the distance across the United States. If you look at the picture, you can see that our moon is definitely much smaller than our Earth. In your books, we put the 4 moons that are across that kind of go across the diameter of our Earth to kind of show there's a big difference between the two bodies. That brings us to that it is 1/4 of the diameter, 4 moons across the Earth, and the moon has much less mass than the Earth. If you look at this picture, it would take almost 82 moons to equal the mass of our Earth. So obviously our Earth is much more massive than our moon. which also affects gravity, because the more massive an object is, the more gravity it has. It also is the reason why our moon's our satellite. It goes around our Earth because of our Earth's gravity. The moon's gravity is 1/6 of our Earth's gravity. The moon rotates on its axis and revolves around the Earth. If you notice, the revolution of the moon is at an angle. We'll get back to that when we talk about eclipses. So the funny thing about our moon's rotation revolution is that it takes the same amount of time to rotate as it does to revolve. That means a day on the moon equals its year. But also, a day on the moon is the same length as a month on Earth. And the reason that it revolves and rotates at the same time is the same reason why we only see always see the same side of the moon facing us. So it takes about 29 days to rotate on its axis, and it takes about 29 days to revolve. This last sentence at the bottom is very important, and you need to understand it. So, as the moon orbits the Earth, the relative position of the moon, Earth, and Sun give us phases.